So today I am discussing a very interesting topic about gravitation, that is derivation of Newton's law with the help of Kepler's law or vice versa. This is very important. So for simplicity we consider the orbit is circular. We also prove in case of elliptical orbit. For in case of simple case, so we consider the orbit is circular. So let two planets, that is A and B, this is the Sun. Two planets A and B, that is this mass m1 and planet B mass m2. The radius of the orbit, that is r1 and r2. So and the angular velocity of A, that is omega 1, and B, that is omega 2. So let two planets A and B of masses m1 and m2 respectively, they revolve around the Sun in a circular orbit of radius r1 and r2. So their angular momentum are omega 1 and omega 2 respectively. Centripetal force, we know, we derive the equation of centripetal force. So F1 equal to m1 omega 1 square into r1, F2 equal to m2 omega 2 square into r2. This is equation 1 and 2. So dividing 1 and 2 we can get, this is the value. So we can write F1 is the centripetal force, Fc equal to, we know, that is m omega square r. Please watch all the videos. So this is the equation of centripetal force. This is 1 and this is 2. That is T2 by T1 the whole square. Number 3. So according to Kepler's law, that is T proportional R cube. So this is in case of first planet, that is for A planet, and this is for B planet. So we write that is T1 proportional R1 cube, that is T2. So this is planet A, this is planet B. So this is this by this, that is T2 by T1 equal to R2 by R1 তার whole cube লিখতে পারি, putting so T2 by T1 equal to R2 by R1 whole cube. So putting this value in this equation, so we can write that is F1 by F2, that is m1 by m2 into r2 square by r1 square, r2 square by r1 square. So we can write F proportional m by, so we can write m proportional, so we can write F proportional m by r square. So this is the force of attraction, this is the mass, this is the distance between the masses. So force of attraction is directly proportional to the mass, and inversely a square of the distance. This is the distance. So this is constant K, constant, that is gm. So F equal to gmm by r square. This is the Newton's law. So this is very important. So this is very important in different exam. Now I come to the last one, that is derivation of Kepler's third law using Newton's law of gravitation. For simplicity we consider this is circular orbit. So this is Earth, this is Sun. So let the Earth of mass m, this is the Earth mass m, moves around the Sun of mass capital M in a circular orbit, this circular orbit of radius r. So this is the radius r. So the time period of Earth around the Sun be t and velocity v. So we can write that is t equal to 2 pi r by v. So squaring on this both side, we can write t square equal to 4 pi square r square by v square. So here we here we multiply here we multiply r here and here, this is multiply here and here, so this is r cube, so v square r. So for a circular motion we can write that is mv square by r equal to g mm by r square. Actually fc equal to that is f. So fc that is centripetal force, f that is gravitational force. So we can write mv square by r equal to gmm by r square. So here we can get that is v square r equal to gm. So putting this value in this equation 1, we can get t square equal to 4 pi square r cube by gm. So this is constant, we can write t square proportion r cube. So this is the Kepler's third law. So this is the Kepler's third law. This is very important. I think all students watch without skipping. This is very important. I think this class is highly helpful. Thank you all my dear students. Thank you all my friends. Please watch all the videos and subscribe and like and share.